We're going to continue our discussion of diazonium ions. Made another diazonium here. This time, though, it's from a primary amine. And in our previous example, it was from a primary beta hydroxyamine. That beta hydroxy was very important. Primary beta hydroxyamine. Because if that alcohol is not there, you get a mess. A big mess. Any reaction that makes multiple products is not a desirable reaction. So the point here is to avoid trying to do things with the primary amine and the diazotization process. Once again, I'll have it drawn out like this for you on the test. And your first step would be cross off spectator, lone pair, minus charge, grab H. So here's your second example where, and yeah, we had a little discussion between videos. This is 8 points to get into the box, not 6. 8 points. Second time we're doing it makes it 16. So we have this. So I didn't mention in the previous video, this is called nitrous acid. HNO2. You learned how to name that way back in the day. And then it was 2 steps, new page, new description, red first, blue second. On exams, you really only have to do it one time on the whole exam if you're going to do this. And then HONO, we're going to protonate it first. HCl. And then it's going to eliminate itself. Lone pair on the O. Resonates in, eliminates the good leaving group. You got your N triple bond O. Nitrosyl cation. Aminophile. Whoa. Didn't like that, so I did it. Okay, what are we going to get? Get your Cl minus and your HCl ready. You're going to use them 2 steps in a row. Tautomerization. And elimination. We still have another H here and still a plus charge. Time to go into the box. Going into the box. You're going to need the same combination. The base to grab the H, HCl to provide an H. First step, better leaving group. Subsequent step, grab H. Sigma becomes phi. Leaving group leaves. And there you go. Interesting products here. Where's this O going to come from, huh? Don't forget, square brackets means this is the same reaction as you started. Every chemical from over here is still available. And there's a ton of water. That's your O. I would just do an SN2 reaction. Keep in mind, lots of water or Cl minus, I really don't care. First step, backside attack, leaving group leaves. That's not any old leaving group either, is it? That's better than an excellent leaving group. How come? Why is it better than excellent? Entropy. It's a gas. Yeah. And second step, deprotonate the oxonium. And you're done. I guess I'm going to need 2 more copies of that allylic diazonium species. Yeah, 2 copies. Maybe I can get away with 1. Yeah. Hey, I'm seeing something. How the heck can I get a chloride over there? Hey, if I could get a cation over there, I could put a chlorine over there, couldn't I? And if I can get a cation over there, I can do an elimination and get this too. Hey, let's get the cation over there on the left where there's tertiary. Resonate, eliminate. Oh yeah. Resonate, eliminate. Make a nice cation. Allylic and tertiary. Oh, come on. That's a nice cation. And then you can make that into both of these. Let's go with the second one first. You gotta take an H from here. Water or Cl minus, don't really care. There's a ton of water. E1. And the other product is SN1 from the same carbocation. Cl minus and we're done. That's it. Love it. Cl minus, where are you? Cl minus right here. Big mess. You got substitutions, eliminations. Lots of good news. And I'm just showing you, you're never allowed to say, see the mechanism previous. So I'm biting the bullet and doing it again. Need to get good at it anyway. Protonate. Yeah. Green arrow. Got your HONO. Nitrous acid right here. Protonate, eliminate. Step 1. Protonate. Step 2. Eliminate. You got your N triple bond to O. This one's almost done. If you have a secondary amine, the story's a lot simpler. Primary, a lot more going on. Can you get me to that final product? Can't even see it. There it is. Well, I think if I attack the nitrogen with the lone pair like I've been doing 3 times now, I'm almost there. That gets me the N double bond to O, which is an N nitrose amine makes this a nitroso group. And I can tell you personally, they're interesting. Typically, the solution is it's a baby blue solution. It looks like the sky in the over the Mediterranean. It's nice. And they have a unique smell that's not so nice. It's not nasty, it's just unique. And I'm glad I'm just remembering it from 35 years ago and not experiencing it again. It was one of the reactions I had to do to get finished with graduate school. Anyway, that would give us an intermediate where there's still the H on the nitrogen, right? So step 2, we're going to scribble our nitrogen off. Sorry, the hydrogen off. Put it there. Step 2, we're going to take it with either Cl- or water. I don't really care. It's step 2. It's got to be baby blue. Appropriate baby blue. Now that we know the product is actually baby blue too. There you go. So secondary amine is going to get you an N-nitrosamine. And there's more to that story. N-nitrosamines are not good for you either. Many of them are carcinogens, cancer-causing agents. So I shouldn't have been sniffing them so much. I think I'm okay though. All right. And there you have it. That's the end. I don't think we have time for a retro, but we're going to start Wednesday with a retrosynthesis, probably from Fall 21, Test 3.